All right, good morning, guys. It's the start of a new week. Let's go ahead and get started with lesson 8. Today's objective tells us I can use the value of a ratio to solve ratio problems in a real world context. I can use the value of a ratio to determine whether two ratios are equivalent. Okay, so today we're going to be given some word problems and we're going to have to find the value of a ratio. Okay? The value of a ratio is going to be a fraction. So if I have a ratio that is 15 to 20, okay? The value of that ratio would be 3 to 4, okay? Because 15 would be 3, 20 would be 4, okay? If we were to build a table, eventually we would have 15 to 20, but that would be our original ratio. Okay, 3 to 4 is our value. Let's move on. Exercise 1, please follow along with notes. Okay, pause the video when I tell you to. Look at exercise 1. Circle any of the equivalent ratios from the list below. So pause the video real quick and write down all the equivalent ratios in a group. Go. You should have paused your video. Okay, so now it says circle any equivalent ratios from the list below. So I have 1/2 and 5 to 10. Okay, 1/2 and 5 to 10 are equivalent. Okay, they both represent 1/2. Okay, the ratio 6:16 to 12:32, they're equivalent as well. Okay, they would all begin with 3 to 8. Okay, so this is 3 over 8. That's the values of our ratios. Okay, now the bottom part says find the value of the following ratios, leaving your answer as a fraction. Okay, so when we write the value, it's going to be as a fraction, but rewrite the fraction using the largest possible unit. Okay, so the value of the ratio 1 to 2 is 1/2. The value of the ratio 5 to 10 is 1/2, like we set up here. The value of the ratio 6 to 16 is 3 over 8, and 3 over 8 again for 12 over 32. So at the bottom says, what do you notice about the value of the equivalent ratios? The value is the same. For equivalent ratios. Okay, so if two ratios are equivalent, their value is going to be the same. Okay, just like you saw here, their value was 1/2. Here, their value was 3/8. Okay, their value is always going to be the same. Let's move on. Quickly, here's a theorem. If two ratios are equivalent, then they have the same value. Okay, that is true. Can you provide any counter examples to the theorem above? No, we can't. This is true. Exercise 3. Tavon is training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race, so while Tavon trains, he rides his bike more than he runs. During training, Tavon runs 4 miles for every 14 miles he rides his bike. Okay, identify the ratio associated with the problem and find its value. Okay, so he's running miles and he's biking miles. Okay, so what's our ratio off the bat? Tavon runs 4 miles for every 14 miles he rides his bike. So our ratio is 4 to 14. Okay? That's our ratio. Now we have to find the value. Okay? So, how are we going to turn this into a simplified fraction to find our value? Okay? How can we simplify 4 to 14 one more time? Let's divide both of them by 2. Okay? And then we write this as a fraction, 2 over 7. That's as simplified as we can get. So 2 over 7 is our value for letter A. Is our value of our ratio 4 to 14. Okay? Guys, this is easier than you think. Don't overthink it, okay? Let's move on. Letter B. When Tavon completed all his training for the Thuathon, the ratio of the total number of miles he ran to the total number of miles he cycled was 80 to 280. 80 to 280. If this consistent with Tavon's training schedule, explain why or why not. Is this consistent? Okay, so we saw on letter A that his value was 2 to 7. Okay, so we need to figure out if 80 to 280 is 2 to 7. Okay, so let's figure it out. 2 to 7, 80 to 280. Okay. What times 2 equals 80? That's 40. Is 7 times 40 to 80? Yes, it is. So 2 to 7 is still the value. Same value, so it is consistent. Okay? Hope you guys understood that. They asked if his training schedule was still consistent because after a while of training, his ratio turned to 80 to 280. Well, just because it has bigger numbers, it still had the same value of 2 to 7. We figured it out here. Okay? All we did was multiply by 40. Okay? It had the same value, which means that his training is still consistent to the value. Okay? Let's move on. Okay, letter C. In one training session, Tavon ran 4 miles and cycled 7 miles. Did the training session represent an equivalent ratio of the distance he ran to the distance he cycled? Explain why or why not. So 4 to 7. Okay. And now, the value we're trying to compare this to is 2 to 7. All right? Okay? We're trying to see if these are equal, if they are equivalent. Okay? So right off the bat, I have 4 to 7 comparing to 2 to 7, or 2 over 7. Okay? And right off the bat, I can tell these are not equivalent. Okay? So I would write down they are not equivalent because they do not have the same value. Okay? We have 4 over 7. Okay? We're comparing 2 over 7 and 4 over 7. Okay? We can write our ratios like this as well. This is times 2, so this has to be times 2. If this was 14, then they would be equivalent, but it's not. It's only 7. Okay, so this is not equivalent to this. Okay, so not equivalent. All right. All right, guys, as it was a short lesson, if you get confused, rewatch the video. Okay, pause it when you need to, or ask me questions after you do that. Okay. Lesson summary: the value of a ratio A to B is the quotient A over B. This is just telling us that if we have a ratio 3 to 4, it is the same thing as 3 over 4. Okay, same thing. If two ratios are equivalent, they have the same value. Okay, 3 to 4 is equivalent to 15 over 20. Okay, same thing. All right, same value. You guys are going to get a problem set. Okay, that looks like this. 4 problems. Please, 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 please try your best. Get it turned in. Awesome, guys. Have a great day.